which was 5, 4, right?
Yeah. Yeah.
So let's take a look at, no, not 5, 4, 5, 3. Here we go. On section 5.3, does anybody have any questions? All right, I didn't think, like I said, I didn't think it was that hard. Nobody has any questions?
I have a question.
Yes. Go.
22.
All right, let's look at 22. List the angles of the sides of each triangle in order from smallest to largest. Well, right off the bat, we already know that Z is going to be
90.
the largest.
Oh, wait, never mind. Okay, yeah. I don't know why.
You good?
Yeah.
Sure?
Yeah.
All right. And now,
I just wasn't sure what 31 and 37 was asking. Like, I didn't know what it was
okay,
asking.
so let me see what it's saying over here. It says, use the figure to the right to determine the relation between the measure of the given angles. So which one's bigger is what they're asking.
Oh, okay. I just didn't
Right,
know
you're
the
saying
relationship.
angle ABD. Well, that's why I gave you solutions.
And I looked at solutions and I still didn't know.
It didn't say?
It said that it was.
It did say.
You mean, oh, it gave you the answer, but it didn't help
It
you
didn't
get the
explain,
answer.
like, what it
Okay. All right, that's good. I'm glad. So now do you understand what I'm
Yeah,
saying,
I know,
right?
I know what I
So
mean.
you're looking at angle ABD. So I'm just going to highlight this real quick just to make sure. Here is angle ABD,
Oh,
and here is BDA. So BDA would be this angle right here, BDA. All right, and you're just supposed to compare those
Gotcha.
angles.
All right.
That's all there is to it. All right, now again, today it's not that much harder. All right, so I think we'll be in good shape. But I wrote out a couple worksheets because sometimes the kids get a little confused. All right, so let me have the homework, please. Let's go, let's go. Let me see it. Chop, 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 chop.
Yeah, I have a question on 32, 30. 33.
Well, I just asked if you had any questions and no one said anything, so I want to go homework. Here we go, here we go. Now, homework.
Oh, this thing you have me like actually.
Thank you.
No, I don't even know why, but I think I like brought up assistance in my office. All the time to come from like a calendar, you know?
Oh my god.
What? I'm not even joking.
Like a cow.
No, like, alright. Ah, let's Nick, have some water.
Okay, now let's go ahead and flip over to the next lesson. Now, you'll be happy to know the reason why we're skipping 5.4 is indirect proofs. We don't really deal with indirect proofs. All right, so some people are happy about that, but indirect proofs really aren't that hard. So today now we're on 5-5. All right. So again, please take a look up here. All right, let's walk you through. All right, again, pretty easy concept. Pretty easy concept. All right. Now it says the triangle inequality. All right. Basically, it's telling you this: that the sum of any two sides of the triangle is always greater than the third side. Look up and make sure you understand what I'm saying now. All right, over here, the sum of the lengths of any two sides of a triangle must be greater than the third side, which hopefully makes sense. All right, but they're just demonstrating. The three sides are A, B, and C. So A plus B has to be greater than C, B plus C has to be greater than A, and A plus C has to be greater than B. All right. Now, here is the other quick little demonstration that I like to make to try to see if it makes sense to you. Look right here. All right, so what we have here is we have two sides of a triangle. Let's say this side measures 5, and let's say this side measures 8. Look up. Come on. Here's 5. Here is 8. All right. If I'm making a triangle and I make this angle as wide as I can make it, what's the largest angle I can make? 180. But is that a triangle now? No, it is not. So if I said this was 5 and this was 8, what's that length right there? 13. Now please watch. All right, that length's 13. That is not a triangle. Now I'm going to take that 180-degree angle and I'm going to make it less than 180. As soon as I'm less than 180, do you see the triangle formed?
Yeah.
Yes. So that third side has to be less than what?
2 times 13 or 13.
Less than 13. Thank you very much. Because this length right here is 13. As soon as I fold it in and make an angle less than 180, I create a triangle. Correct? So if that was 13, as soon as I make an angle less than 180, that side now is less than 13. Now, I can go from 13 all the way to, now I'm folding it, making the triangle as small as I possibly can, and then all of a sudden, it overlaps on this side. So now technically we call that a 0-degree angle, all right? But if this was 5 and this was 8, the side is getting smaller and smaller, it's less than 13, it's getting smaller and smaller and smaller, and all of a sudden you're looking right here, and as soon as it becomes 0, what is this length that overlaps right here? 3, thank you very much. It's 3, because if this is 8 and this is 5, and we fold it all the way over, it overlaps by what? 3. So now you're supposed to visualize, if that's 3, and I open the angle here, Walker, if I open the angle, that side now is greater than what? It's greater than 3. All right? So the third side of a triangle, we say, has to be less than the sum and greater than the difference. So if this is 5 and this is 8, the third side has to be less than 13, because right here is 180 degrees. Now it's less than 13. And now this angle is now 0. The distance between these two endpoints is now what? 3. So as soon as I make it greater than 0 degrees, that distance is now greater than 3. Is everybody with me?
Yeah.
All right. So the third side, we say, is very easy. If you have two sides, the third side has to be less than the sum and greater than the difference. That's how simple the lesson is. All right. So with that, all right, let's look at question number 1. Is it possible to form a triangle with the given sides? Right? Yes or no? Is it possible?
Yes.
Can you have a 3, 4, 6?
Yes.
Right? And how the quickest way is to say, take the two smaller sides. If you take the two smaller sides and it adds up to greater than the third side, then the answer is what? Yes. Not equal to, it has to be what? Greater than. So number 1 is definitely what?
Yes.
Yes. Let's look at number 2. 2 is definitely what?
Yes.
Very good. No.
Yes, I could.
Oh yeah, because it's
Right, I just said the sum of the two smaller side has to be greater, cannot be equal to. All right, cannot be equal to. All right, so number 3, definitely a what?
Yes.
Yes, equilateral triangle. All right, number 4, definitely a
No. Yes.
yes. Again, you're always looking at the two smaller sides. All right, if those add up to larger than the third, you're in good shape. All right, number 5,
No.
definitely a no. And now number 6,
Yes.
definitely a yes. All right. So now we're going to find the third side, the possibilities. All right. So for the third side, this is going to have to review your inequalities here. All right. So the first thing I want you to do is write down x. Right. You want to be less than the sum. So I have to be less than what? I have to be less than 7. And then I have to be greater than what? and I have to be greater than 5. That's how I want you guys to write that. I know it's been a while. All right, I'm doing this with the algebra kids right now. Okay, so again, that's the inequality that I want you to be able to write. That means the third side is somewhere between what? 5 and 7. Everybody good with that? What?
Why 7?
Greater than the difference and less than the sum. Greater than the difference, less than the sum. So for number 8, x is going to be, or the third side is going to be less than 30, and it's going to be greater than 6. Told you, very simple.
How do you use 6 again?
18 minus 12. Less than the sum, greater than the difference. All right, here we go with number 9.
Yeah. Did that on our work. Yeah, but we can still.
So x is less than what?
7.
And greater than
4.
4. All right. Number 10. X has to be less than
90.
and greater than
74.
74. Not a big deal at all. Shh, come on. Let's get it done, remember? All right. So again, suppose you have 3 different positive numbers arranged in order from least to greatest. What single comparison will let you see if the numbers, well, we just said that. What are we looking at? If the sum of the two smallest is greater than the largest. That's the easiest way to describe that. If the sum of the two smaller sides is greater than the third side. That's what you could write down. All right, now the next part, I just need your attention. Okay, we're just going to walk through it. All right, I'd kind of like you to just not be too rusty with the proofs because occasionally we're going to do one, but we're winding down. All right, so if I flip this now, I decided to go ahead and just walk you through the first one. All right, so here we go. Listen carefully. It says, using the triangle inequality theorem, you can use the triangle inequality theorem as a reason in proofs. All right, so we're going to try to figure this out now. All right, it says, given that triangle ABC is congruent to triangle DEC, we're going to try to prove, and this is where I want you to kind of highlight, we're going to try to prove that AB plus DE is greater than AD minus BE. All right. Now again, the reason why I want to concentrate here is because there are 2 or 3 proofs. I think they're kind of tricky. All right. So let's see what we can do. All right. First of all, of course, it says the triangles are congruent. And again, I want you to try to stay with me. If you're not seeing something, speak up. Now, we know that AB plus BC is greater than AC. You're all good with that, right? And that DE plus EC is greater than CD. Now, the first thing that comes to my mind here is, how in the world am I supposed to see that? How would I know to even start there? Come on now. Now we're trying to work on the techniques about trying to get a little bit better. All right. Now, the thing that I'm trying to show you is that I'm trying to get these involved as quickly as I possibly can. Everybody see that? That's what I'm trying to get involved. All right. And so if I'm trying to get those involved, I'm looking at AB. I'm looking at the relationship with DE. I'm looking with Yeah, see, I do think that's kind of tricky. All right, I do think that's kind of tricky. All right, that's what I'm saying. Kind of follow me through. All right, starting that off that way would be kind of tricky. Now, remember, I'm trying to prove I need to get A, B, and DE involved. Now, let's look at the next part. It says that AB is greater than AC minus BC. Everybody see that? What did they do? I always try to tell kids, look at the previous step right up here, and this relationship here, and this relationship here. All they did was what? Right? Does everybody see that? They just moved the what? They just moved the BC over, right? So AB is greater than AC minus BC. All right? And then the same procedure here. All right? All I did was I took DE and I moved over the EC. All right? And again, that's just the subtraction property of equality, so that's not a big deal. All right. And now, again, I'm trying to get A, B, and DE involved. So now, do you see how I have AB right here? Well, I should do this. So I have AB and DE, correct? Now I can add those two things together. And again, I'm telling you, I think that's tricky. That's why I'm just trying to show you. All right. So if you add those together, now do you see how that's helping? Because that's this part of the proof. Does everybody agree with that? And then what? Then if I added those two together, I'm going to have to add what? I have to add this together. So that becomes AC minus BC plus CD minus EC. Now, for me personally, what I would have probably done on there is I would have just lined up the addition and lined up the subtraction and saved myself some time. Everybody see that? So again, what I want to do now is I could just cross this out. Does everybody agree with that? Because how I would have added it, I would have just right off the bat said, add these two things together, and then these would be subtracted. Does everybody agree with that? So that way I wouldn't have to do the commutative property. I would just have that listed right there. Does everybody see that? All right. And then they just what? They factored out a negative. Does everybody agree with that? All right. Which I think they should call it factoring, but they just call it distributive property, so I don't really care about that. Now what? Now I have these two things grouped together and these two things grouped together. Now, why is that important? Because that's exactly right. What you're doing is you're looking at this right here, the AC plus CD is equal to what? AD, and then BC plus EC equals what? BE. And he's correct. That's simply the what? The segment addition postulate. All right? And now what are we going to do? Substitute in. All right? Because why? This part right here now, if we can look at this, this AC plus CD becomes what? Becomes AD. And then BC plus EC becomes what? BE. And it's just a straight substitution. All right. So now look, I think that's difficult. The reason why I think that's difficult is because most of my kids say, I wouldn't know to put this in there. All right. I wouldn't know to start out like that. All right. So generally it would probably be what? Just some kind of fill-in proof here. All right, to help you out. All right. But see if you can follow that. I think that's interesting. All right. Now, because that was so interesting, now we're going to try to fill one in ourselves and see if we're doing. All right, come on. No whining. I heard that. Number 1. All right, let's read it real carefully. It says PL is parallel to MT. PL is parallel to MT. Now again, I want to go ahead and mark that. All right, mark it on your figure. PL is parallel to MT, and K is the midpoint. So if K is the midpoint of PT, then I'm going to go ahead and mark that. All right, I'm going to mark that. All right. Now, what I'm going to highlight now are the things that I'm trying to prove. I'm trying to prove that PK plus KM is greater than PL. All right, that's what I'm trying to prove. All right. Which, does anybody, without even looking at the proof, can we say that this one should be much easier than the last one, in my opinion? All right, the reason why it's much easier is because we can talk about, if we're just looking at it, we're talking about the triangles are congruent, correct? And then we can say that the sum of two sides is greater than the third side. And then we're probably going to make a what? A substitution. All right, that's how we can relate these two to this one. That's what I think anyway. All right, so here we go. Let's see what we can do. All right, first off, it says PL is parallel to MT. All right, that is definitely given. So let's go ahead and fill that in. Good, so somebody got 1 point correct. All right, now let's mark. Why is angle P congruent to angle T? Somebody who's brilliant. Yes, very good. Those are congruent because they are alternate interior angles. So alternate interior angles are congruent. All right. Now from there, K is the midpoint. Given PK is equal to KT.
Definition of midpoint.
All right, we are on fire here. I told you. Definition of midpoint. Shh, 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 shh. Definition of midpoint. Hey, come on. Now, it's telling us that we have vertical angles, so we should be fine with that. So someone tell me.
Angle PKL is congruent to angle MKT.
We are great. Angle PKL is congruent to angle MKT. Those are vertical angles. All right. Now let's go ahead and mark that just to make sure.
Yeah.
All right. And now we can say the triangles are congruent. All right. So triangle PKL is congruent to triangle TKM by angle, side, angle. All right. I'm pretty happy with that.
Where's the angle headed?
Okay, so let's review now. Blow it up and see. Shh. Oh, just be quiet. Guys, I am trying to get through, and some of you guys think you're comedians or whatever. I'm not interested in that right now. I'm trying to get through the homework. I've heard complaints about how much homework you guys have. So every day I rush in here and try to get as much work as I can done for you. All right? And you're interrupting me constantly.
Oh, I know. I see.
All right? Ask a question if you need it. Other than that, be quiet. Angle, side, angle. Everybody good with me now up through 6. All right? Now, again, I'm simply looking at this up here. I need to get this involved. I need to get this involved. Now, the triangle inequality theorem. What could I say next?
PK plus KL is greater than PL.
All right, I'm going to write that down. You tell me again.
PK plus KL is greater than PL.
Is greater than PL, did you say?
Yes.
All right, let's see if that's good. All right. So hold on a second. Let me just verify. PK plus KL must be greater than PL. Now listen, I'm not sure how, because some kids ask me all the time, like, I can't see that. How do I see that? And I'm saying, honestly, I don't know. All right? You have to look up here. You're trying to verify this. So what are we noticing? I'm trying to write that as close as I possibly can. So I chose, or hopefully he chose PL greater than PL because that's part of the proof. And then we have what? PK. Now we can't say it's KM because KM's part of what? The other triangle. But you're trying to write the inequality as closely as you can to the proof so it's easier to get to the solution. All right, does that make sense? All right. Anybody have any issues with that right there? All right. Now we're doing corresponding parts of congruent triangles or congruent. So somebody else have a thought. Tell me, Bridget.
Could you do MK plus KT?
Now wait a minute now. Now listen to me. You're right. You're probably right. But here's what I'm asking you. Because I think we should look over here. They want us to use the corresponding parts of congruent triangles, correct? So now here's what I'm trying to convince you guys of. Right now, look at where I'm at. I'm at this statement right here, and I'm at this statement right here. So what is different? What is different? The KM. And the KM changes with what? Shh, don't help her. KM. Look right here. I'm going to highlight it up on the board. Don't help her. Here's KM. Here is what it is supposed to be.
Oh.
So what's true about KL and KM? They are congruent. And how do I know that KL is congruent to KM? But nope,
Oh.
because the midpoint was PK and KT.
Oh.
What are the triangles? The triangles themselves are what? Congruent. Therefore, corresponding parts of congruent triangles are congruent. So I have to say first that KM is congruent to what? KL. That's corresponding parts of congruent triangles are congruent. All right? So now, why is PK plus KM greater than PL? All right, substitution. Now listen, I always tell everybody, that's nothing I can do for you. All right? I personally feel as if you should go home and you should look over those two proofs. I feel like you should look over those two proofs. Right? It's not about you doing it on your own. I'm helping you. I know the first one especially is very tricky. The second one I feel like it's okay. All right? Now, the next part here, guys, flip through this now. This is just a lot of overkill, right? This is like a 5-minute lesson. All right, but hold up. This is the one I want you to spend time on, 17. Try to fill that proof in yourself. Hold on, Walker. Then I can cross out 18. I don't care about that. All right, then I'm looking at 5.5. More what?
That's easy work.
Is it the same page?
It says at the bottom top sheet.
Oh, I grabbed the wrong worksheet. No.
No, you didn't. No.
Is it D? Yeah. All right, so I did make a mistake then.
You just need to pick another page.
Yeah. Yeah, I grabbed the wrong page by accident. All right. So then what I did here, guys, sorry, I meant to put the other one. So listen, so do me a favor. All right. The solutions I also put down there for some reason because I know the proofs are hard. But what I would like for you to do is, since I accidentally put the wrong one, I would like for everybody to try to just flip through 17. Is everybody hearing me on this? Look what I'm saying. I know the answer's there. It's kind of annoying. All right. But the only way you're going to get better at doing these little inequality proofs is by doing that. Okay. So the only thing you have to do on this page right here, even though it has the answers, is look at question 17. Is everybody with me? Then The answers are there for a reason, and then I want you to do practice 5-5. And you got a little lucky. All right. So practice writing the inequalities properly. Yes, Walker now.
Do we have to explain why
No, you just put yes or no. All right. It's the same reason. All right. Any questions? Any questions? All right. Finish it up. Especially look over the proofs.